Assalamu alaikum. Hope you all are fine. So today we will start our new chapter, that is alkyl halides and amines. So in this video we will learn about the alkyl halides. So firstly we will discuss about the classification of alkyl halides. There are three classifications of alkyl halide, that are primary alkyl halide, secondary alkyl halide and tertiary alkyl halides. So firstly, with the primary alkyl halide, why it is said as a primary alkyl halide? Because when the halide is attached with a alkyl group, and this alkyl group further attached to a single or bonded alkyl halide, so it will form a linear chain and it will known as a primary alkyl halide. When the carbon that is attached to the halide group, and this alkyl group then further attached to two chains of alkyl, it will known as secondary alkyl halides. And the tertiary alkyl halide, when the carbon that is directly attached to the halide group, and this carbon further attached to three alkyl groups, that it will known as tertiary alkyl halides. So, the next is the nomenclature of alkyl halides. So first rule is name is based on longest carbon chain. So firstly we will find out the longest or parent chain, and if that chain contains a double or triple bond, that will consider as a parent chain. So the next one is number the carbon of parent chain beginning at the end nearer the first substituent, whether alkyl or halo. So it is rather alkyl group or halide group. We have to uh, name or number them the lowest, because we can see in the first example the numbering is starts from here, and the lowest number gives the methyl group. This is the methyl group, and the other we will count is 1, 2 and 3. On 3 there is a bromide group, the halo group. So we will prefer the lowest number. Okay, this is the lowest number. The second number, there are two groups that are same, that is methyl group, and one is the halo group. So we will name it as on the fifth position of fifth carbon there is a bromo group, so we will name it as 5 bromo. And because of two groups that are similar, we will name it as the carbon number 2 and 4. There is two methyl groups, so we will add dimethyl. And the longest chain that contains carbon atoms, that are the 7 carbons, that will name as heptane. So the other example is when we count from here, one carbon, second carbon and third carbon, or third carbon there is a methyl group, and from we will number from the left side. We see the 1 and 2. On the second carbon there is a halo group, so we will count from the from this side, and there is a bromine that is attached on the second carbon. We will see the name as 2. On the second position carbon there is a bromo group, that will name at 2 bromo. And on the fourth and fifth carbon there are two groups that are same, and we will name them as 4 and 5th positions. On fourth and fifth carbon atoms, there are two methyl groups, so we will name it as dimethyl. And the carbon chain that contains that is a parent chain and that contains 7 carbon, we will name it as heptane. So the other rule is, if more than one of the same kind of halogen is present, use a prefix di, tri and tetra. So we can see this example, the dimethyl and dimethyl. So if the chain contains three or four methyl group, the same groups, whether it is a halo group or alkyl group, we will name them as the carbon position number. And di if there are two same groups, or tri if there are three same groups, and tetra if there are four same groups attached on the chain. So the last rule is, if there are several different halogens, number them and list them in the alphabetic order. So there are four halogens that are mostly used, that are fluorine, chlorine, bromine, and iodine. And if the chain contains all the four halogens, we will name them as the alphabetic order. Okay. Basically, the bromine will comes firstly, then chlorine, then fluorine, and the last one is iodine. So the next is the formula and the common name and IUPAC names. So firstly, we will discuss about the first formula, that contains a methyl group along with the halogen, that is chlorine group. So we will name them as, the common name is methyl chloride. We will take the alkyl group first, and then the other group, whether it is halogens or any other groups. So basically, the common name is methyl chloride, and their IUPAC name, we will have to firstly write the group name, that is halogen. We will prefer the halogen first, and then the alkyl groups. So basically, we will name them as chloromethane. And the next one is the same, ethyl bromide and bromoethane. And third one is also the same, and propyl, because the propyl has a linear chain or normal chain. We will when we write the IUPAC name, we have to number the carbon that is attached to the halogen group. So first carbon, we will name them as 1-iodo-propane. And the other example is the halogen that is attached with the second carbon of the chain. We will name them as, the common name is isopropyl chloride, and the IUPAC name is, the number of the carbon that is attached with the halogen or other group. We will number them 2, and the group name chloro, and the chain name is propane. So the next example is a 4 carbon chain, and in this is the simple chain, that is n-butyl bromide, and its IUPAC name is 1-bromobutane. The other example of a butane is the halogen that is attached with the second carbon of the chain. So it will name as secondary butyl bromide in the common name, and when we name them as IUPAC name, so we will have to number them, the carbon number 1 and 2, because we have to name them the smallest or least digit, that is 1 and 2 second carbon. And if we count from here 1, 2, and 3, there will be a halogen that is attached on the third carbon. So we will prefer the least number, and we give them a least number, that is 2-bromobutane. The other example is also of 4 carbon, and the halogen is attached. So this compound common name is tertiary butyl bromide, and its IUPAC name is, because it has uh, parent chain that is of 3 carbon. Okay, 3 carbon chain. So the middle carbon or the second carbon has a bromo group and a methyl group. We will name them as 2 bromo because on the 2 or second carbon position there is a bromo group, so 2 bromo, and on the second position there is a methyl group. We will name them as 2 methyl and um, propane because their parent chain contains 3 carbon. So the other example is the 4 carbon chain, sorry, 4 carbon compound and a halogen that is attached with the first carbon, and its common name is isobutyl bromide, and its IUPAC name is 1 bromo because 1 carbon is directly attached with the halogen group, and the second carbon has a group that is methyl, so 2 methyl propane. The other example contains a 5 carbon compound, and its common name is neopentyl because this whole structure name as neopentane, and when the halogen attached to the carbon uh, of the terminal carbon, and it will name as neopentyl bromide, and its IUPAC name is we have to find out the parent chain. So the parent chain is consists of 3 carbons, and uh, on the first carbon there is a halogen, and on the second carbon there are two groups that are methyl groups, and we will name them as 1 bromo 2 dimethyl propane. So the next is physical properties and structure. So firstly we will discuss the structure. It has we have taken a simpler alkyl halide, that is chloromethane or methyl chloride. So firstly this is the structure, and this is because of the halogens that have higher electronegativity than carbon. So first physical property is halogens are more electronegative than carbon, and due to the more electronegativity, the other physical properties are carbon and halogen bond is polar, so carbon has partial positive charge because of their high electronegativity, and it will impact that the carbon will contain a partial positive charge and chlorine will contain a partial negative charge due to high electronegativity difference. So basically the next point is carbon can be attacked by a nucleophile because carbon contains positive charge and nucleophile contains a negative charge. So if the nucleophile is stronger than the negative charge that is attached to the carbon, and when the nucleophile is stronger than the negative charged species that is attached with the carbon atom, it will easily replace this negative charge and attach with the partial positive carbon. So the next point is halogen can leave with the electron pair. When the halogen leaves or negative partial negative charge leaves, it will leave with the electron from the carbon, and it will leave as a negative charge. So this is the whole topic. uh, Thank you so much. Take care. Allah Hafiz.